So here we are with another nomenclature video. Maybe I make these because you need help in doing this. Maybe I make these because I find it fun to do. So let's take a look at this structure. So right away we should notice that there is both a ring structure and a linear component. So as I mentioned in previous videos, you have to decide which one is the parent, the ring or the linear portion. It can't be that you bleed into it. You can't count, 1, 2, 3, 4, 5, 6, 7. It's one or the other. The dividing point's right here, or anywhere that there's a ring and a linear acyclic structure. So we see that this has 1, 2, 3, 4, 5 carbons. And then we see that this one has 1, 2, 3, 4, 5, 6 carbons. So right there, this one's pretty straightforward. This linear portion also happens to have unsaturation and functional groups with priority. So pretty much we know right away this is the longest chain. That means that the ring here and this right here and this right here are either functional groups or substituents. The OH is a much higher priority than either alkyl or chloro groups. So this is the highest priority functional group. So we're not going to name it hydroxy. That's what you would name it if you were trying to treat it as a substituent. But since it's the highest priority functional group, we're going to treat it as the functional group and name it as a suffix, OL. This is cyclo, because it's still a cyclic ring, and there's 5 of them, so it's pent, and there's no unsaturation in the ring, so it would be normally ane, but because it's a substituent, we don't name it like that with an A and E. We name it YL, cyclopentyl. And then the chlorine's pretty straightforward. It's just chloro. Now we have to determine the numbering. Is the numbering going to be 1, 2, 3, 4, 5, 6? Or is the numbering going to be 1, 2, 3, 4, 5, 6? Like I said, when it comes to numbering the locants, you have to first start with the primary functional group. If it's a functional group that's the one that's changing the suffix, such as in the alcohol here is changing the ending of the name, or it's going to an OL. So we got to focus on the functional group OH. In one of the locant directions, it's numbered 3. In the other direction, it's numbered 4. That's the minimum, the 3. So right there, that's why it's like a series of rules I told you that you kind of go through only if the previous one didn't narrow it down enough. This narrows it down just in one shot. So the numbering is going to be the one that makes this 3 all. So we choose the red one, the red numbering. So by choosing the red numbering, that means that the chloro is going to be 4-chloro. The cyclopentyl is going to be 4-cyclopentyl. And the unsaturation is going to be at the 2. So this is an unsaturation, so it's a double bond. The double bond unsaturation we name En. So this right here, En for double bonds, and it you number it. I think I said 2 earlier. My apologies. Forgot what direction we were going. we're going this way, 1, 2, 3, 4, 5, 6. So you always number it based on what the lowest of the two numbers are that are connected to the carbons that make up that unsaturation. There's always going to be two carbons associated with the unsaturation, a double or triple bond. One carbon on one side of the double bond, one carbon on the other. And those two carbons will have two different locants. In this case, 1 and 2. You'll number the unsaturation based on the smaller locant. Makes sense? We're always talking about minimizing locants. So this is going to be not just ene, but rather 1 ene. So we're kind of labeling all these parts and pieces, and that's why, just like in our play posit video, you kind of gather all this information and then you finally assemble it. We forgot one last piece of information, which is the length of the chain. And this chain is, if you notice right here, 6 carbons. So 6 carbons is hex. So that since it's a 6 carbon chain, since it's a 6 carbon parent, we name it hex. If it was no unsaturation, it would have been ane and no functional group. But it does have a functional group. So we can't have the either. It's gonna it's going to have an OL here. And it's not AN because there is an unsaturation. It's gonna be EN. Hexanol. But we forgot our locants. We need to put our locants in. So let's go ahead and put the locants in. Assemble the name down here. So first of all, let's gather all our substituents. This is really just two things. The cyclopentyl and the chloro group. Now, the cyclo is part of the name when it comes to alphabetizing. So it's still the C and the C. So they both start with C, but this is CY and this is CH. So the chloro group is first. So 4 chloro, 4 cyclopentyl. Then the hexanol part. So hex. And then the substituent is 1. The locant is 1 ene. And then the alcohol is at the 3 carbon, so 3 ol. Some people may write it as 4 chloro, 4 cyclopentyl, and then dash 4, not 4, excuse me. Dash 3 hex 1 enol. Oops, I forgot a dash. I forgot what goes between the dash and the enol. Dash 1 dash enol. Now I mentioned in class, and this is where I would say, for example, if there is 2 locants, or maybe more than 2, but there's a locant associated with the unsaturation and locants associated with the functional group, you can't pull both of them out because then it would be 1,3 hexanol. But is the 1 associated with the ene or is the 3 associated with the ene? That would be the question. And there would be actually 2 different structures you could draw based on those 2 different options. And so you can't pull both of them out. The ideal situation, I believe what IUPAC prefers, is you put the locant next to the thing it's associated with. So 1 ene, 3 ol. So that is the name of this compound, and that is another example in the books. I hope this helps with the nomenclature. If you want maybe videos on other concepts and topics, please let me know in class or by email, preferably even, so I have a note of it so I can try to put it on the schedule if I can find some time. I have some ideas also that I might try to shoot. Anyways, hope this was helpful. Talk to you later.